This is Dispatch This. Apollo Client is a GraphQL client and state management library, and it's the most popular way to work with GraphQL on the client side. It's downloaded nearly 2 million times every week, and we recently released Apollo Client 3, which is a new version a couple months ago. It introduces new ways to use Apollo Client as a single source of truth for client-side state. So I got a great intro. I'm Khalil. Yep, I'm a developer advocate at Apollo. I help developers level up with Apollo, GraphQL, and TypeScript. And I'm also pretty passionate about software design principles and best practices. And I actually sniped a really cool copy of some books on Shrudi's shelf back there. We're going to talk about that later. But I also love music. And in another life, I'd probably be spending my time just making noise. So today, at least in the React world, some of the most common approaches to client-side state management are Redux, React Context, and Apollo Client. So Redux was very popular for a long time, and I think that popularity came from the fact that it was a very simple mental model to understand. We had reducers, actions, and action creators, and even thunks, and with this, it introduced a really nice structure that even while it had a little bit more boilerplate than other approaches, it was repeatable and understandable. I think that kind of structure really made an impact on the community. When React Context came out, using the use reducer hook, it provided ways for us to keep that same mental model of actions and reducers, but in a way that didn't even require Redux. And then we have Apollo Client, which is a completely different beast. It doesn't use that same mental model, and we don't have that concept of actions or reducers. And I think for people moving away from Redux or people who are currently using React Context, it could be confusing to figure out the Apollo way of doing things. But the great benefit of Apollo Client is, despite being different, you don't need to write any of that boilerplate architectural stuff you'd normally need to do with Redux or React Context. So the question really is, how do we decide which one to use? Well, maybe we should first ask, what is it that we need from a state management solution exactly? So first thing's pretty obvious, it's storing state. We need to be able to put state somewhere on the client side, of course. So that may include some remote data that we need to pull in. It may include some local state, some stuff that's not on the server. And we need the ability to combine both local state and remote state and have them live elegantly together on the client side. Second thing is we need to update state. We need to be able to handle what's stored locally, and we need to update it. And sometimes this happens immediately, like after an operation, like a get or a delete or an update if you're using REST, or after a mutation or a query if you're using GraphQL. And lastly, reactivity. After state's been changed, it's pretty common that we want to notify pieces of our UI that relied on that state that it has been changed and that they should present the new data. Ultimately, these are the three pillars of what you would expect from a state management solution. And all three of these do a really good job of getting it done. Yeah, they all have slightly different ways that they're achieved in each approach, but the high-level goal, storage, state changes, and reactivity, they're all realized. So then, how do we decide which one to use? What makes sense? Well, state management is complex. There's no doubt about that. And we know that this slows down developers. Sometimes state management code can account for like 40 to 60% of a project's code base, and that's a completely made up number, but it's also kind of accurate, if you know what I mean. To better illustrate what I mean, let's look at a 5,000-foot view of what I believe to be a generic architecture for most client-side apps. First, we have presentation components, and they don't do much other than present, preferably in a nicely styled way. And presentation components have UI logic. Render this if you're logged in, or otherwise render this instead. UI logic is responsible for doing something with the data that's coming into a component, and then creating user events in response to things like button clicks, hover states, or key presses. And next, we have our container component. I sometimes call these page components because it seems like it's a page that's responsible for hooking up all the machinery to get the features working on that page. So you might not call it a container component anymore, especially since the advent of React hooks and thinking about everything in terms of just functions or hooks. But the reality is we need something, whether it's a function or a class, to enable reactivity. So something that knows how to get data from the store, and something to enable us to take those user events from presentation components and connect them to the right place, whether that be a React hook, a service, or a Redux thunk, or an action creator. That's what I believe the job of the container component, or page component, as I like to say now, actually is. It's to act as the glue in the middle that stitches everything together. And we mentioned something about a store, right? How does this come into play? So for example, imagine we have a to-do app and we're working with to-do objects. When I click the Edit To-Dos button, it's possible that I might need to reach inside of the store to run some logic that decides what we're going to do next. I call this interaction logic. It's decision-making code that determines what we're going to do next in response to a user event. And that's typically either a command, something that makes a change to the system, or it's a query, something that returns data but doesn't really make any changes. So moving forward with interaction logic, it's often not enough to just perform that operation locally. Like with edit to do, when we want to edit that to do locally on the client side, most of the time it also relies on some remote data. So before we change that data we're seeing on our screen, we want to update data remotely using an API first. So we'll issue an operation like a mutation if we're using GraphQL. And now we get into all kinds of infrastructural stuff. In that fetch logic, we have to handle creating the payload, so turning it into the shape that the backend needs it to be, assigning headers to the request, specifying the resource location, sending off the request and getting the response. And then in the state management code, we need to shape the response into the format that the client needs it to be in, attach any local state variables to the response objects, and then figure out a way to uniquely add, merge, and remove data from the store. And finally, we need the UI to update. We need that data to flow back all the way through to the presentation layer. So if you look at this, you'll actually kind of find that this is about half the work. You know, we can kind of see that visually. And at Apollo, we gave a name to this stuff. We believe that this is the work that should happen within the data layer. The data layer holds arguably some of the most challenging tasks that we have to figure out how we're going to address on every client application. And using a bare bones approach like Redux or React Context, you might find yourself creating the exact same infrastructure and solving the same problems in every app. And you might find that that's time consuming. The Apollo client library handles the entire data layer for you. So that's pretty cool. It means we don't have to worry about this stuff. And that's kind of like developer productivity plus. So here's how this works. If you decide to use Apollo client, you start out with all that challenging data layer stuff already addressed. You get an answer for this stuff from day one. And then here's the rest of the things left to do. Not only are the rest of these things here important, but they're what makes your app special. This is the stuff you can't just pull off the shelf. I want to say that there are 3 steps to getting started with Apollo client. The first step is configuring the cache. And that very well might just be to connect to a GraphQL API. Then we need to query for the data we need. And 3, we write mutations to change data. This is great. Storage, updates, reactivity, right out of the box. Apollo client gives us a set of APIs to configure, fetch, and update our client-side state. We just got to learn the APIs. So in Apollo Client 3, we've introduced improvements to each part of the library. The first major improvement is around the cache. We've introduced something called cache policies, which introduce elegant ways for you to implement patterns like pagination, pipes, default values, and local state management. Local state management is actually my favorite part of this newest release. We've improved the story here by retiring local resolvers and replacing them with this new feature called reactive variables. Lastly, we're giving you fine-grained control as to how you get access to the cache. In Apollo Client, there are several different ways to update the cache, and depending on how much control you need, there's an API to address that. The rest of the slides in this talk will be based on a simple to-do app that I've put together on GitHub. It shows how to use the new AC3 features and how to build different versions of a to-do app using local state, remote state, and the old local resolvers approach that will still work in AC3. In this latest version, we made installation a lot simpler. By installing @apollo/client, you get access to all of the core Apollo Client utilities and extensions. Here's what we normally do to set up the client and the cache. First, we import them. And then we create an instance of the cache. And then we create the client, telling it where to find our graph and giving it an instance of the cache. And with this basic setup, we can actually pull in remote state using queries and make changes to backend services using mutations. We don't need to do anything special past this point to start working with GraphQL data. One of the first things we could do is pull in a collection of data. We do that by asking for the data we want using a GraphQL query. So we'll come over here to this container component, this active to-dos list. We'll import the query. Then we'll import the useQuery hook from @apollo/client, pass the query into the hook, maybe also handle some async states. And then finally, we can pass the data to a presentation component to be displayed. It might look a little something like this, a list of to-dos rendered like that. So behind the scenes, when we use the useQuery hook, a lot happens. And a lot of work is abstracted away for us. It forms the request, sends it off. It keeps us up to date with those async states, which I actually recently learned there's another word for this. It's meta state. It's state about state. And it also normalizes and caches the response. By caching the data, anytime we ask for it again, Apollo Client's smart enough to just know to pull it directly from the cache instead of making another network request for it. Maybe it's a good idea to understand how data gets normalized and what that looks like in the cache. By default, Apollo Client uses the type name plus ID fields to uniquely identify data. So what we're looking at here is the raw data inside the cache after fetching all those to-dos from earlier. It's relevant to know how the cache works a little bit because it'll affect us when we get into mutations. In this next pattern that we'll explore, creating a new item, we could do so by writing a mutation the same way we wrote a query. There's a small important thing to note here though. See where we're asking for the new to-do? By including the new item in the mutation response, the cache is smart enough to identify that something new was brought in. And anytime Apollo Client sees new data, it normalizes it and caches it. So in a component, we can import the mutation, use the useMutation hook, pass the mutation into the hook, handle some async states again, and then hook this up to receive user events from a presentational component. So let's see what happens. Okay, so we've added this fourth to-do. We hit enter, and it looks like it's getting saved on the server, but it's not showing up in the UI. So something's not quite right here. Well, all right, so let's dive a little bit deeper. In the browser, we could actually see what's stored in the cache directly. So looking into it, we could see that we have all our to-dos here. There's to-do 1, 2, 3, and there's 4 right there. So, okay, so this fourth to-do's there. It's normalized and it's cached, but it's not in our cached collection of to-dos. You can see that this is an array of to-dos that are actually just references to the ones stored flat on the cache. So why isn't this new to-do getting ended to the end of this array? Okay, well, it's because the cache doesn't make assumptions about how we want to update cached collections. So when we did the query to get all to-dos, we created a local copy of some of those to-dos. When the cache sees new data coming in that it hasn't seen before, it will always normalize it. It'll always compute the uniqueness and then add it onto the cache flat. But it will not assume how we want to use that new data to modify our existing cached collections. And this is a good thing. Mutations in deciding how our existing collections stored on the cache should change, well, these are all application-specific operations. To Apollo client, all it knows is that we've invoked a mutation. It doesn't know the specific behavior that we'd like to carry out. Only we, the app developers, know this. For example, an add to-do operation adds to the end of a list. A remove to-do splices an object from the array. And an edit to-do updates a to-do in place within the array. This is a small price to pay for abstracting pretty much the entire data layer responsibility away and left to be handled by Apollo client. So yeah, we need to tell Apollo client what behavior we want it to take when interacting with cached collections after mutations. And we could do this using an update function. So if we go back to our mutation, we can pass in an object as an argument. And then in that object, we can define an update function. The update function is provided with direct access to the cache APIs and the new data that was just created that came back from the server in the mutation response. And what we want to do here is add the new to-do to the existing array. So we'll pull the new to-do from the response. We can use an API called read query to execute a query to get the existing to-dos from the cache. And then we'll use the opposite, write query, pass in the query that we want to set the new value of, give it the new data, which is going to be an array, of course. But this time, it'll be all of the to-dos that were just there, plus this new one that we just added. So let's try it out. Let's see what that looks like. Great. It works. So we can see that the to-do is not only saved to the backend, but it triggers a re-render of the view, and we can see that the list of cached items was updated. And if we look a little bit closer, we go back to our cached collection of to-dos in the console, you can see it's there now. So when we're writing this update logic, we generally recommend that you use the read query and write query APIs, because with these, you can accomplish about 95% of what you'll ever need to do here. But with AC3, we also released a set of new advanced cache manipulation APIs that you could also use, and you can check those out on our AC3 docs on cache.modify, cache.evict, and the garbage collection API. So now let's talk about local state management. And this is my personal favorite improvement from this new release. If you were to look at our docs on local resolvers, the old AC2 way to perform local state management, I think you might find that the API is a little bit verbose. And this is actually what we've heard based on feedback from the community. While it was generally liked that local resolvers shared the same mental model of how we implement resolvers on the server side, came at the cost of writing a little bit more code. So we wanted to improve that. We're phasing out local resolvers. They still work, and they'll still continue to work in AC3, but it's interesting to know where they came from and why we're moving away from a technical standpoint. Local resolvers borrowed ideas from this package called Apollo Link. They're wrapped around the cache in a way that when we resolve data, the cache itself wasn't really sure if fields were being resolved from remote state or from local resolvers. And that kind of made it hard to trace. So we aimed for something more reliable and predictable in this new approach. This new approach, which is constructed from the ground up, is called cache policies. Cache policies let you dictate for a particular type and for a particular field within that type what the cache returns before reads and before writes to that field. There's a ton of features packed into this thing, but I'm most excited about the fact that it introduces cleaner patterns for local state management, things like pagination, pipes, filters, and several other common problems that we need to solve when building client-side apps. And the API is pretty light, and it helps us write much cleaner, less repetitive code. So here's an example of a common pattern, initializing a default value. So here we have a cache policy. So on any instance of the person type, on the field name, for that field name, when this is read from the cache, if there's no value set already, what we'd like to do is set it with the default value of the string unknown name. Otherwise, we'll just return it with the value it already has. This is a very basic example, but there's another new feature that cache policies can be combined with that makes local state management a lot more enjoyable to work with. And that's reactive variables, a new AC3 feature. These act as containers to variables that we'd like to enable cache reactivity for. When we change the value of a reactive variable, it'll notify the cache, and if it's being watched, it'll trigger a re-render if you're using React. This means that reactive variables can be changed from wherever you want, however you want, and that's a huge improvement over having to do all your local state management updates in local resolvers. Let's say we wanted to build the entire to-dos app from scratch using local state only. It's a lot easier to do that now. Maybe first we'll define the structure of a to-do type in TypeScript. Do some more data modeling here. And then we can set up what we want the initial value to be. In this case, an array of one to-do. And then let's create the reactive variable, to-dos var. And we do this using the make var function. We could pass in the initial value at the time of creation as well. And then let's go over to our cache policies where we can hook it up. So on the query type, anytime we ask for all to-dos, the to-dos field in our schema, return the current value of the to-dos var reactive variable. This right here is how we connect reactivity to the cache. If we were to go over to another part in our app, we can write a query for these to-dos. And in Apollo Client, the way to tell the cache to try to resolve certain types of data from the cache only and never from remote state is to use the @client directive. So this here will only ever attempt to pull to-dos from the local state. And then we could do the same thing we've done here, pass a query into our useQuery hook, and fetch that data, and then give that data to a component to display. Now, let's talk about mutations. Instead of actually writing mutations the same way we write queries, we have a lot more say over how we want to update our local variables. So the truth is, we could do this however we want. We could actually use simple functions now. In this example, we have a delete to-dos function that when composed with a to-dos var reactive variable, it gives us a function that enables us to delete a to-do from local state using the ID. So invoking the to-dos var gives us all the to-dos. Then we could filter by ID to create a new list of to-dos without the one we're deleting. And then we could save it back to the to-dos var reactive variable and trigger a re-render by passing it in as an argument. So again, in case you're sleeping, it's these cache policies and reactive variables used together that gives us a much better local state management story. And I think that's pretty cool. There's a lot of cool stuff in AC3, and I'm just barely scraping the surface. So what have we learned here? We learned about the 3 basic pillars of state management solutions. That's hold state, make it possible to be updated, and making sure that things are reactive. We also learned that this is about half of your client-side architecture. We call it the data layer. And it can be pretty complex to build and maintain it. So that's why we wanted to do it for you. So you can focus on that stuff that actually matters. And if you use Apollo, there's 3 things you need to know how to do. 1, that's configuring the cache. And we've seen that there are a lot of new APIs to make local state management a lot more enjoyable. Then we need to know how to fetch data, both local and remote data using queries. And we mutate that data using mutations. And understanding a little bit about how the cache works under the hood is helpful because now we've traded in building this entire architecture every time for just knowing how to use the APIs that handles it for us. So depending on where you are in your journey, there's different ways you could get to where you need to go. For example, I always recommend that if you're getting started, stick with the read query and write query APIs to implement your update logic. And then look into the new cache.modify and cache.evict APIs for how to get more fine-grained control over the cache. So there's some resources here in the docs I'll share for you. And I just want to say thank you. And you're not alone on this journey. If you have any questions at any point about using Apollo Client, you could always reach out and chat with me on Twitter, even if just to hang out. Thanks again.